This video consists of 5 parts. Part 1 is the demo, about 5 minutes. Part 2 is the same demo but shown operating on the actual display, 5 minutes. Part 3 discusses some more details, 7 minutes. Part 4 is some additional details regarding operating the turnout, 4 minutes. And Part 5, which is the last part of the video, just goes over a review of all the commands used to operate this display. That's about 12 minutes. Signal. So if this LED is blinking and if you can see it, that means the mini panel is sending a signal to the command station. So let's turn this thing on and demonstrate it. Here's my on switch. And when I power this up, you can hear maybe the sound in the diesel. I've got this set up so I push a push button down here to start the mini panel in operation. That's a manually programmed honk of the horn that lasts about 4 seconds. There's a reed switch in the track down there. When the bell starts ringing, that means the engine went over the reed switch. There's a magnet on the bottom of the locomotive that activates that closes the reed switch and sends a signal to the mini panel. 3 toots on the horn means it went into reverse, so it's coming back now. Here's the reed switch here. Again, it's deaccelerating when the bell starts ringing. That means it went over the reed switch. Forward. Now this switch will throw in about 3 seconds. 2 toots means the engine's starting up and forward. Again, right over the reed switch, you can hear the bell ringing. It's deaccelerating. Single toot means it's stopped. Now it went into reverse. You can see the reverse light came on, and 3 toots to signal we're backing back up. Went over this reed switch here. It's deaccelerating. Bell went off. That means it's stopped. Switcher goes straight. Now this sequence is starting to repeat. And this is just to keep repeating over and over again until this will keep repeating over and over again until we reset the command panel, reset the mini panel to take it out of its sequence. I got the configuration variables 3 and 4 on that locomotive set to about, I think, 40. Configuration variables 3 and 4 control the acceleration and deacceleration respectively, so it gives the appearance of momentum. I believe I'm running at about a speed step 8 just so it keeps it moving kind of slow like it was in a yard or something. Now it repeated the first part of the sequence again. Like I said, it would keep repeating this all day. I'm going to reset. I just connected terminals 32 on the mini panel, which is the reset, so it took it out of its sequence. Now this thing is sitting here idling and it won't go anywhere until I start it up again. But that's basically the demonstration of how this thing works using an NCE DCC mini panel to automatically control the system running point to point. Okay, here we are on the actual display. I'm going to push button number 6 if I can find it here, which will start the point to point. There's 3 toots for forward. There's our bell. That means it hit the read switch. Went over the read switch, I should say. Pauses for about 4 seconds. There's a reverse light. Now it's backing up. Okay, there's the bell. That means it went over the read switch on this end. Now the minute that switch will flip, there goes the switch to curve. Now it's starting up again. Okay, there's the bell ringing. That means it went over the read switch on the incline. Pause for 4 seconds and then back up. There it goes into reverse. You can see the reverse light went on in the cab. There's the bell started ringing again. That means it tripped the read switch on the front end. Now the cycle will start repeating all over again. That switch will go back to straight in a minute. There it goes to straight. Now it'll start down the straight path and repeat. I'm going to lift up this building. It shows how you can see how Mark Anderman put the NCE snap it that operates the turnout. He put that in the extra capacitor all in a block of foam, and that gets hidden under this plastic-built building to cover it up. And that's all being controlled. Here's the control panel here for the various loops and the NCE mini panels under this cardboard box over here in the corner. I just put the box to protect it from any possible accidental coffee spills or anything like that.
And you're going to push this button and hold it in with that thumb of yours. Push this button right here, okay?
Hello, I'm James Ingram for AutoControls.org. We're going to demonstrate here an NCE mini panel controlling an S-gauge train running point-to-point on 2 alternate loops. Somebody asked me why do this automatically. This is intended to be part of a 2-day display. It'll be running several hours each day. It'd be rather tedious to sit here and operate this thing manually point-to-point and throw the switch. And on top of that, we're going to have intending to have 2 circular loops outside of this thing that will be also running more than 1 trains automatically, so it'll be very tedious to try to control this all manually. Now, although this demonstration is done in S-gauge, keep in mind this could be any gauge where the engines have the standard NMRA compliant DCC decoder. In the previous video, 804, we used this same mini panel to control this S-gauge engine plus an N-gauge engine running in a circle plus a large-scale engine running point-to-point. How this is going to work, the engine's going to start here, get down the straight path, stop at the end, wait a minute, come back to here, wait a minute, then go up the curved path, stop and come back here and stop, and then the cycle will repeat. I've tilted the mounting base up here. Normally this would sit flat, but I've tilted the mounting base up to show you the mini panel. The North+Coast+Engineering command station is here, this black box. The mini panel is sitting over here. And one reason I tilted this, it may or may not show on the camera, but there's a little red LED here that'll blink whenever this thing sends a signal. So if this LED is blinking, and if you can see it, that means the mini panel is sending a signal to the command station. I'll go over a couple more details of this system. Again, here's the NCE command station. Over here is the mini panel. And you can think of this mini panel as just being like another cab. Here's a normal cab that you use to operate the North Coast command station, but you have to sit and of course push buttons and turn the throttle up and down yourself to operate this. You can think of this mini panel kind of like being if you had a normal cab with a robot controlling the cab. The robot would push buttons on the cab for you, and you could sit back and do nothing but watch, and the robot pushing the cab would run the train for you. And that's basically what this thing accomplishes. You program this mini panel to do certain instructions, and it does it automatically, like a robot controlling your trains for you. Over here, this little green device is the North+Coast+Engineering Snap It, and they advertise this as being made to control an HO twin coil switch machine, and it's got a 1,000 microfarad capacitor. It's a little green, a little blue cylinder here that's built into this to give extra amperage, to have enough amperage to operate a twin coil switch machine. However, we found when we hooked it up to this American Flyer switch, which is kind of current hungry, it wouldn't even budge this thing. So my friend Fred Cupp was kind enough to experiment with different size capacitors, and he found when he added a 4700 microfarad capacitor, which is this extra cylinder sitting here, to the stock 1000, so we've got a total of 5700 microfarads. We finally had enough current that it would throw this American Flyer switch. This is S-Helper service track, this gray stuff, which is recently manufactured. This is an old American Flyer switch from the 1950s. I would use an S-Helper switch if I had one, but they're not currently available due to manufacturing problems. Now, and note this thing gets both its power and its command from the track. Since it's DCC, I don't need to send separate wires to this thing to throw it. All I need to do is send it power, which is what this connection here is doing in the track, and the command signal is also going through the same connection. there's 3 reed switches in this system. One is right here under the track, and then there's a second one up here on the trestle. These happen to be Railroad Concepts reed switches, which are kind of nice because they're all protected, but any reed switch should work. That's the second reed switch, and then the third one is over here under the track here. So there's a magnet on the bottom of the locomotive, and when that magnet goes over a reed switch, that reed switch temporarily closes, and the reed switch is connected to terminals on the mini panel, so the mini panel can sense when the reed switch is closed, and hence it knows to go to the next command. This diesel is programmed so when it goes over a reed switch, the mini panel will start the bell ringing for 8 seconds, and there's really 2 purposes to that. One, ringing the bell tells me that the thing has detected the reed switch, and plus it just adds a little additional action to the display. And when it goes over the reed switch, it also sets the speed to the 0. So as soon as you hear the bell start ringing, that's when the speed has been set to 0, and this thing will coast a little bit because of the momentum that's set on the locomotive. Now this is a S-Helper service diesel we're using here, and it has a Soundtrax Tsunami sound decoder in it. And this decoder automatically gives you 1 whistle toot when the diesel stops. And then when the diesel goes into forward, it'll give you automatically 2 whistle toots. And when the diesel goes into reverse, it'll automatically give you 3 whistle toots, which is sort of, I guess, the way the prototypical railroad practice is. And one thing to note, if you watched the earlier video 804 from about a year ago, this same diesel was used in that video, but it had the original Soundtrax decoder, not the newer Tsunami. And the original one didn't have those automatic toots when you go into forward to reverse, so I had to manually program those into the mini panel, which is more tedious. But having the newer decoder makes it nicer because you don't have to separately program 2 toots for forward or 3 toots for reverse. The diesel does it automatically. And this has been customized with a strobe light on the top, which is probably not prototypical for Erie Lackawanna diesels, but again, it's just something to provide a little bit of extra action so the diesel's doing something even when it's sitting stationary. And that strobe light and stuff was added by Chick's Hobby Shop in Gibbstown, New Jersey. Let's take a closer look at the snap-it and the switch here. Again, the green thing here is a North+Coast+Engineering snap-it, and I put a voltmeter here, which I hope the needle shows in the camera, and this is actually charging up to about 22 volts. My command station is set for about 11 volts, I think, so this is charging up to twice the voltage on the track, it appears. But you can see this thing is this needle's maxed out at 15, but if I throw this switch to curved, you can watch the needle. It is curved. I'll throw it to straight. Watch the needle here. You can see how that's charging back up, and it takes a minute to get fully charged back to 22 volts. I'll throw it again to curved. Again, the needle goes down. Now, if I try to throw it now, even though it's almost all the way charged, it didn't throw. So you got to really wait till this thing charges back up to have enough voltage to throw it. As I mentioned earlier, the stock capacitor is 1,000 microfarads, and this one that Fred Cupp added is 4,700 microfarads. If you're not an electronics person, you can sort of make a crude analogy with water glasses. If you think of the stock capacitor, which is here, being this glass, 1,000 microfarads, it holds that much water or that much current, and when you release the water, you get a certain amount of flow of water or current. And here's our bigger capacitor or bigger glass, which holds 4,700 microfarads. The numbers really don't mean anything here. It's just that it's holding more. If I tilt this one, I get more water released or more current. And when we tilt both of them together, that would be, 5,700 microfarads worth of current or water to throw that switch that wants more current. just for comparison here, I've hooked up an LGB switch to this system. Now instead of the snap it like we were using before for these coil switch machines, the LGB switch can be driven by what they call the switch cat, and notice there's no capacitors on this at all. Apparently it's not necessary. LGB designed these switches to be very low current draw. I think these draw about 1/4 of an amp or so. There's actually a little DC motor in there, almost like what you'd find in an HO engine that drives these switches. So these take about 1/4 amp versus these S-gauge switches all take about 3 amps, it seems. And that's a big difference. You can drive about a dozen of these with as much current as it takes to drive one S-gauge switch. And that's nice for hooking up, like if you're going to drive these things with reed switches, you can drive this directly with the reed switch. If you try to drive this directly with the reed switch, there's so much current it burns out the reed switch, so you have to use relays. So it's much easier to use these type of switches for automatic control. But I've got the push button in my hand here that I can manually control this, and you can see it can be flipped back and forth almost instantaneously. There's no requirement to wait for anything to charge. Again, that's because it's drawing a very low amount of current. So from my own personal point of view, I wish the S-gauge switches would have been designed more like these things that work off a lot lower current. But since I'm probably the only person in the world, or one of the few people in the world who cares, that's probably not going to happen anytime soon. Command file we're looking at here can be accessed by using the forwarding link track2.com/info/805. And as far as the way these commands are done, there may be better ways to do this than the way I'm doing it. I'm just showing you this for reference. But we start with a push button connected to input 6. So when we push that button, that brings us to memory location 6, step 1, and that's a command to select the loco 452, which is the one we're using. The next step turns on function 5, which is a strobe light. Theoretically, you'd want to turn function 8 on, which is the sound, but if you do that, for some reason it turns it off. The sound seems to turn on automatically, so we don't send that command. The next step, F0, turns the headlights on, and pretty much the whole way through this, anytime we send this group of commands, F0 to F4, the headlight will keep that on all the time. And by the way, I should mention the way they set the mini panel up. You set these commands in groups, like there's an F0 through F4 command you send, that you can send any combination of those on and off, and there's the F5 through F8 command. You can send any combination of those on and off. So at any rate, we got our strobe light is turned on here. Well, starting over, we selected our loco, turned the strobe light on, turned our headlights on. Now we're going to link to input 21, so that takes us up to memory location 21. By the way, I might mention there's basically 2 ways you can have commands executed in a given memory location. One is by like a button or a reed switch or electric eye connected to that input, which is the case with memory location 6. That's what starts us here. And the other way is to come from a previous command, like a link command. So this link command takes us to memory location 21, and we'll go there next. Right, here we are at input 21, having come from, jumped up from input 6. Up in the upper left-hand corner, this is just a reminder that tells me what functions control what operations on that locomotive. Over here on the right is a schematic of the layout. If you recall from seeing the video, on the left end we're calling that point A, where the locomotive starts from. It goes first straight out to point B, then it comes back to point A. So that's basically 2 parts. Part 1 being out to point B, part 2 being back to point A. In part 3, it throws a switch curved. It goes up the spur to point C, and in part 4, it'll come from point C back to point A. So going over here to the instructions, now these memory locations could be accessed also by a push button or a reed switch or electric eye, but they're not. But like I said earlier, they're accessed by coming from memory location 6. It jumped up to 21, and the first 3 steps are just no ops. Now step 4, accessory 9 is a switch, and norm means throw it straight. So basically this command throws the turnout straight. Go into the next step, and the memory is set continuous here, so it'll just go from one memory location to another memory location continuously, either till you hit a stop statement or till it loops back to the beginning. So the next step here, memory location 22, set the speed forward to 6, so that starts it traveling forward from point A to point B. Now we have a 2 4-second delays. They give you delays in either a 4-second increment, which is what I'm using, or I think the other one is a 1/4 second increment, but we've got 2 4-second delays, so that delays us for 8 seconds. Now after that we turn the horn on, which is function 2. You can see function 0 and function 2 were sent with this command. As I mentioned earlier, I'll always be sending function 0 to keep the headlight on, but here we're sending function 2 to turn the horn on. So we have another delay of 4 seconds total while the horn blows. Then after that 4-second delay, we turn the horn off by sending this command. This just says keep the headlights on, F0, but turn the horn off. Now our next command is a wait until input 12 is closed. Input 12 is the reed switch on the right end. So the locomotive will keep going until input 12 is closed, which happens when the locomotive travels over this reed switch. So at that time, when input 12 is closed, it drops to the next command, which says turn the bell on. That's what this is, function 1 here. So the headlights are still on, F0, we turn the bell on, and immediately after that we send a speed 0 command, which means the locomotive will start coasting to a stop. This is 2 4-second delays, 8 seconds total of delay. That'll ring the bell, and that's pretty much the amount of time it takes the loco to roll to a stop. This command, next command, turns the bell off. Again, no function 1 for the bell, just function 0 for the headlight. Now we sit here and wait for 4 seconds at the far right end, point B, and do nothing. And then now we're ready to start part 2, reversing to point A, and we send a speed reverse 6 command, and now we're traveling from point B back to point A. Continuing with our code from point B back to point A, we're right at this step here, I believe, memory location 24, step 4. We sent the speed reverse 6 command, which gets us heading from point B back to point A. So basically, we're out here at point B and we're traveling to point A. So we're going to go back and keep traveling till we come to the reed switch at the left end, which is input 11. So that brings us to this input memory location 25, step 1. Wait until input 11 is closed. That means wait till the locomotive with the magnet on the bottom of it goes over top of the reed switch. It's connected to input 11 on the mini panel. So it'll wait until that happens, and then at that point it'll turn the bell on, again sending function 1 with this command, turning the bell on, immediately set the speed to 0, delay for another 8 seconds while the bell rings. After 8 seconds, we're going to turn the bell off, and then we'll stop for, I'm out of range here, I say. Let's back up for a second. Waited for the reed switch to close. We turned the bell on, speed 0, wait 8 seconds while the bell rings and the locomotive coasts pretty much to a stop. After 8 seconds is done, after the 8-second wait is done, turn the bell off, and then wait at the end for 4 seconds. This set of instructions for part B right in here for going from point A from point B back to point A is basically the same as the first set, except we're going in reverse, and I didn't put the 4-second blowing of the horn in. So now we're ready to throw the switch and go on the curved route. Starting what we're calling part 3 in our command sequence here. Our locomotive has just run the straight section. It's come back again to point A, so now we want to throw the switch to throw the turnout to curved and go up the spur that's on the incline to point C. So let's scroll down and look at the commands for that. If we go to input 27, which is where we left off before, we're sitting at point A on the left end. Again, we select accessory 9 and the setting is reversed. What that does is that sets the turnout to curved. So we set our speed forward to 6 and we wait until we go over input 12, and input 12 is the reed switch. It's up at the top of the grade, so we're just waiting till the locomotive gets to the reed switch, and at that point we're going to turn the bell on and ring the bell and immediately send the stop speed, the speed 0 command to stop the train, and we'll wait 8 seconds while the bell rings and the train coasts pretty much to a stop, and at that point we'll turn the bell off. Now we'll just sit there for 4 seconds at the top of the grade at point C. So now here we are to B. So now here we are to the fourth and final part of our little command sequence. We're going to go backward from the top of the grade, point C, backward to point A. So we send a speed 6 in reverse command to start the locomotive backing up, and again we wait until input 11 is closed. That's the reed switch at the very left end of the little layout where the locomotive started from. So our locomotive will travel, and the mini panel will wait at this step until the engine's magnet travels over that reed switch. It's connected to input 11 of the mini panel. At that time, we'll turn the bell on, send a speed 0 command, ring the bell for 8 seconds, and then we'll turn the bell off. We'll delay for 4 seconds and do nothing, and then we send the link to input 21, and what that command does, that takes us back to the top of the sequence. We'll scroll up there now, going back to it brings it back up to this point here, input 21, where we send again we set the switch straight and we start repeating the sequence. So this system will keep repeating this little sequence of going back and forth on the straight siding, then back and forth on the curved siding. It'll keep repeating that little sequence over and over, hour after hour, until we reset the mini panel to stop the operation. So that's basically how the commands work for this little system.